John here. Welcome to part 3 of how to 3D print a giant 7-segment LED. How to design one so you can print it anyway. We're still in the design phase here. So here's where we left off. I added a little bit of dock to some of the functions that I didn't dock last time. And we're rendering up, we're previewing the back of the segment here. Okay, so what I want to do in this segment is add the divider in here for the two strips that go in here so that the strips don't move back and forth or up and down. So in the back, it's relatively easy to do the basic thing that we want to do. So what is that? It's going to be a cube, essentially. And let's put it on center. Make it a little bit easier to keep the thing aligned right. And that's going to be... I didn't mention last time, I added a divider height variable along with the width from the introduction there. So I got a width and a height. So the width is going to be the fatness of the thing in the x-axis. The y is going to be the length of the divider, which is going to be the inside length of the segment. So we have that right in here somewhere, the outside inside length right there. And the z is going to be the divider height that I just mentioned. I added up here. Now, because we're centering this, it'll be printed centered on the origin. Let me put a marker in here. Let me highlight this, little debug highlighter. As you can see, so you can't even, it's not in the right spot. I got to lift it up in Z, but the question is how much. I need to lift it up more than the back of this segment. Here, let's do this just for fun. Let's do a difference here. Let's put like a cutting plane in here. Let's take the back that we're rendering now and subtract a cube from it that is 100 by 100 by 100. Center equals true. Then we'll translate it to where I want it to go. In X, we'll leave it alone. In Y, we'll move it towards ourselves, 50, so it will be in the foreground. What we're going to do is we're going to cut off this bottom half of the segment right at that axis there. And then the Z, we'll leave that alone. This should do it, right? Oops, I went the wrong way. I got to go minus 50. Fine. So now you can see where this shape really is. Oop, I guess if you zoom in too close, then the previewer gets a little confused. There's a bug in OpenSCAD. Anyway, you can see where the divider is. It's clearly centered on the z-axis, and it's otherwise hiding inside the back of the back, so to speak. Let's leave this on for a minute and figure this out. So what do I really want to do? I want to translate. It's actually fine in the X and Y. We just need to lift it up in Z. So how high do we need it to go? Well, if it's divider height in Z, we need to come up that much over 2 in the Z. And we also want to go up to account for the thickness of the back itself. So that's the back thickness right there. So if we move it up now to here and preview it, clearly that is in the right spot if it renders it properly. Okay, so that looks pretty darn good to me. Let's turn the debug back off. Okay, that looks good. Let's do a full render to make sure it's not up in the air. The fact that I have two volumes right here means that it's not up too high. If it is up too high, what happens is that means I've created another volume. So let's go ahead and add 5 to the Z height. And clearly this is going to be floating in the air. It's not connected. So if you do a full render and look down here, it's got another volume, right? The inside volume of this shape, the inside volume of this shape, and the outside volume of the whole thing is what OpenSCAD is counting. So in other words, it is lying down on there. There's not a tiny little gap between there. It might actually be that it's too far down low. I might have made a mistake and it really is dipping inside. We can figure that out by adding like some really tiny number here like that and say if I lift it up even the teeny bit, is there a gap in there? And this just changed to a 3. So yeah, there is a small gap there now, and there wasn't when it was just like that. Full render. So clearly that's the proper place for that to be. So let's turn off now our little test code up here. Now, if this is all we really wanted, we'd be fine, but that's not what we really want. This will come a long way to helping you put this together. But what you really want to do is kind of put a top on here. That way, the LEDs will not have a tendency to fall up inside the LEDs. And yes, when I built a prototype using this particular design, mine did. They popped up in one of the LEDs, and then it looks terrible because the diffuser can't deal with it if they're not laying flat. It just looks hokey. So we want to put a cap on this, sort of like a T-top. But if you literally put a cantilevered T-top on this, you couldn't 3D print it because it would be 3D printing in the air. You can have the printer add support and do it that way, but then you need to remove the support, and that's a pain in the butt. Oh, and then you can use water-soluble support. No. No one cares what it really looks like, by the way, because it's going to be inside your LED segment anyway. So what I did was this. I took and put a cylinder on top of this. So when the printer prints it, each time it comes up in the Z height, I should have left that debugger thingy on. Let's go ahead and put this difference back in. I just did a few undos because we're going to want to have a look-see at how I put the top of this thing on here and see what's going on with that. So let's put a cylinder on that. What I was talking about, I can only zoom in so far, I guess, is that, well, actually, if I do a regular render, it should be fine. Okay, there we go. If we zoom in and we put a round thing on here, what'll happen is as we print it, as it gets higher and higher and higher, it'll print only like one line out here, and it'll have a chance to stick to this edge. And then when it prints the next height, it'll put another line out there, and so on. So it'll have a rounded a rounded shape, so that it won't try and print the entire cap all in one layer, because it'll have a tendency, the printer, when it extrudes out here, it'll just fall down on the floor, make a mess in there. So you can do this right now. This translation puts this cube here, this cuboid shape, on center. I'm looking at right there. Okay, if I put a cylinder on here, I would want to put the cylinder obviously up higher than that, maybe center it on here, and that's what I'm going to do. So in order to translate from here to here, I just don't go to divider height over 2. I'm going to go to the full divider height plus the back thickness. That's where I want the center of my cylinder to be. And I'm going to just sort of guess on this one. I'm going to make the cylinder diameter 4. The height of the cylinder, you might think it's going to be fine. Let's go ahead and make it the same as the inside length. This will be problematic later on, you'll see. We also need to rotate this. I'm not sure which way to rotate. We want to rotate it in the x-axis. And right-hand rule, so we want to go 90 degrees in X. And now we have the previewer is overly zoomed in again. Let's go ahead and render it. Now you saw when it was in preview mode that it was sticking up. It's actually over here because I forgot to center it. All right, it's also looking really big. It doesn't have that many facets on it. So that's too big. Not really. It's not really too big. It's just too big vertically. Let's squish the thing. But let's get this other stuff right first. First of all, let's give it some more facets. Let's give it 30 facets. Okay, now we got some resolution on there. Let's squish it. So after it's been rotated, we can squish it in the Z. Let's scale. 1 by 1 by point, I'm going to just guess, 0.6. I think that's what I did one other test. Now that's pretty darn big. Do a full render. Okay, zooming in now. Now you can see the LED strip can sit in here and this will hold it down. That's pretty darn big though. Let's go down to about a 3 on this. Do a render. That doesn't look too bad. If you make it too small, it won't hold the LED strip down, because remember when we defined this width here, which I call the slot width in this program up here, it includes this 0.75 millimeter fudge factor. So if this thing is 0.75 millimeters wide right here, the LED strip will actually be able to fall through here just fine and dandy. So a quick back of the envelope, if this diameter is 3, this is really only 1.5, and actually, surprise, that is not really big enough. So maybe we should put it back to 4. There we go. And let's squish it a little bit more. Maybe 0.5 is better. We're getting closer. That's not too bad. If I do it too much, it'll become too flat underneath here. Like this might be too much. See how flat that is? The printer might try to print all that in one pass with many extrusion paths running longwise on here, and then it wouldn't work. So that's probably too much. I'm just guessing. We'll know more when we actually print a test. This is still pretty round. So when the printer prints this first layer in here, it might make one overhanging cantilevered pass, and then the next one will have another one, and so on till it gets out here, and then it'll start building up this. So this is probably fine. You got to experiment with this and decide what works best for you. That definitely will do it. Now there's something else that I happen to know from when I was playing around with my printer and working on the same thing. If you actually do this, see how the end is all together, because I made the height of this cylinder equal to the inside length of this segment. Printing all this together, my printer, when it comes to the end and it turns around and comes back, it will momentarily pause here and then come back. And what happens is you end up with a big blob on the end of this, just because the head stays there. Even if you try and do even if you do a retraction or something to try and stop the extrusion from going on, for a short while, it will still be extruding because it's got that pressure to get rid of in there. So for a very short time, it will spend pausing on the end, and this will get thick and ugly and blech. So what I did on mine, after I did a test and found that to be the case, I subtracted a little bit of distance. Now, technically what you want to do is base it on your LED length, because if you make the shorter and shorter LEDs, you don't want to subtract so much that you don't even have one of these if you only had like one LED, right? So you want to say LED, back it off, LED length times like maybe 0.3 or something like that. So even if you said I only want one LED in here, this would still be 1/3 of an LED long, because you're going to back this one in a third, back the other one in a third, and then it'll remain 1/3. So that's a pretty reasonable choice there, and having it like this is fine. That'll come out pretty good for you. And this, this is pretty decent. Now we can go ahead and remove this difference again. Actually, I'm going to go somewhere with this. Let's go ahead and put a star in here to get rid of it. That comments out this entire statement, and I'll just put another one right there. Boom, there we go. Now we have the whole segment rendered. Move this to the left a little bit. And you can see that it's a little bit, the retainer, the LED retainer blob on here, the top looks really reasonable there, okay? And this is literally roughly how mine, the one that I printed, is set up here. And this works on my printer anyway just fine. You're going to have to experiment with yours to see if you have the same kind of problems I had with the extruder, putting a little too much material on the ends of these. Okay, fine. Now, by the way, if you don't know how to use some of these OpenSCAD features, have a look-see. I got another playlist. I'll add it in the comments here. Kind of a introductory and a how to use OpenSCAD as a whole, with any of the bells and whistles I'm using here are all covered in that other playlist. So, and by I'm talking about this, if you don't know what that means just comment out this whole difference and all this stuff inside. Okay. Now, this is all fine and dandy, but it would be nice if we could change the number of strips in the LED. So now the problem will be if I change it to one strip, you don't want a divider in there if you have only one strip. This doesn't belong there. And I'm also looking at this. Clearly, if you have only one strip, the inside width is not equal to the 1 times the slot width for the one LED plus the divider width. It doesn't need to have a divider if you only have one strip in there. So this is okay for the original design, but if you want to be able to tune this, so maybe I want 3 of them in there. Clearly that's not what you want here. You want to have 2 of these dividers in there. So if we make this thing more tunable, more useful, let's leave this set to 3. What you really want to do is say, look, the total inside width is going to equal the number of slots, the number of strips times the slot width plus the number of LED strips minus 1 times the divider width. That is actually the correct width. Now, if I only have one of these, now it's still going to put the divider in there, it's going to be 1 times slot width plus 0 times the divider width. This is the proper width now for a 1 strip segment. All right, so let's put this back to 3 and then go back to where we're putting this in here and put a little code in there that'll create the right number of these things and put them in the right spot. So how do we do that? Well, I can put a for loop in here. And I'm going to say x equals, and I'm going to create a range of values for x. And then for each one of those, I'm going to put one of these guys in there. And I'm going to say move to the x location that this guy will generate and put them, center these dividers on the x that is going to be generated in there. All right. So how is that going to work? Is this otherwise all fine and dandy? I think so, because originally it was just 0, and that's where you wanted it if there was only one. But what you really want is if there's 2, it needs to go over here, which is seg inside width divided by 2, negative of that, right? So we're going to come over here and then move over to the right, 1 slot width plus the width of the divider, or half of that width, that is, and then put one there, and then move over again that much, put another one on there, and so on. And do that one for the number of strips minus 1. So how does that really going to work? So let's go to minus the inside width over 2. Now, we'll revise this. We'll start naively and then move forward. So we're going to start over here on the left, and then we're going to move over what? The slot width plus the divider width. So the slot width, we haven't used that directly yet. Where's the slot width? This guy here, which is just a quick review. The slot width is up here somewhere. It's the LED width plus the little fudge factor that make it a little wider so that the 3D printer, when it is imperfect or imprecise, we don't end up with too small of a slot and the LED strip doesn't fit in there. So every time we do one of these, we need to move over slot width plus the divider width. And we're going to end when we get to plus seg width over 2. So for the most part, this should work if you finish putting your closed curly down here. All right, so I said I want 3 strips, and this kind of makes sense, except for somebody put an extra one over here on the left, and that actually makes sense because I started at minus seg inside width over 2 and said put one there, move over, put one here, and so on. So I really don't want to start there. I want to start there plus where the first one belongs, which is going to be plus this thing here. Now I got the 2 dividers that I really want. Now, are they really in the right spot? I'm not 100% sure, but we can do a quick check and say, look, if there's only supposed to be 2, this better be in exactly the middle, and it is. So there's a rough clue that it's probably okay. If we have 1, there better be none of them, and that makes sense, right? Because I said start at minus segment over 2 plus something, and end when I get to seg width over 2. Now, seg width over 2 is really going to be equal to slot width without the divider width on it. So that's why you don't get any of them over there if you go back and check the math. So I think this is correct for this. So if you wanted to put 4 in there, you should see 3 dividers, and the middle one should be exactly in the center. And you know what? It is not. So we're not quite out of the woods. Something's a little bit off here. If we zoom in on that, clearly that's not in the middle. In fact, if we put more of them on here, it'll probably get worse. Of course, we need an even number to get one in the middle. You see how suspiciously it's just to the it's to this edge. It's not in the middle, so we're probably not starting right. Let's now go back, and this is what I had in mind when I said let's keep this around and cut this in half so we can get a better look at how the alignment is. I did a full render so I can zoom in without the previewer getting confused. So that is definitely the left edge and not the center that it should be. Let's go back to 2. 2 is also the left edge. Oop, now I got to do a full render again. Whatever that bug is annoying. So, okay, this is easy enough to solve. It just means that I didn't start it in the right spot. So it's minus segment over 2 plus slot width plus the divider width. This is the problem here. When I say go over here and then go over the slot width plus the divider width, what happens is I don't want to go over a full divider width. I want to go over the plus the divider width over 2 for the first one. This is fine for the increment between each one of them, but the first one needs to be to the left by half of the divider width. And then the rest can go from there. Now this is on center. Clearly that's okay. Let's go ahead and go for 4 because that'll be having one in the middle as well. Let's go full render here. That looks pretty darn good. So I'm pretty sure that's fine. The time will tell when you put your LEDs in there, when this one fits and that one does not, and so on. If that happens, you'll know what code to come back to down here. So you're going to have to definitely print some test prototypes and get these all tuned up. Again, we have volumes equal 2, so they're not up in the air and doing anything weird like that. This is all good. So I'm pretty sure that's what you're going to want to do for your tunable number of strips so that you have the right dividers in there. So next time we will do more work on the snap-in feature that'll allow the front and backs to snap together. Oh, I also got to knock these sides out, but I think this video has gotten too long already. We'll do another one where we talk about how to knock these corners out so when you put them together, the wires can flow together into this segment that might meet with this one over here. So I'll see you next time.